Now let's look at how to model probability of a customer buying the subscription, and what are the factors that will determine the probability. The two main factors are what is the current movie going rate of a given customer. Okay. Now the overall average is 0.77 for the entire United States, but obviously some people go to movies at a much higher rate, and some people go to movies much lower rate. So we have to deal with that. But in any case, the current movie going rate is going to determine whether a customer is inclined to buying a subscription or not. The second one is the break-even number of movies with the current subscription rate we've assumed is 9.95 and 8.97, and it is 1.1 movies. So that is another factor. Okay, so the larger the difference between the current movie going rate and the overall break-even point on either side is going to affect the probability. The the smaller the current movie going rate, the smaller will be the probability. The larger the current movie going rate with respect to the break-even point, the higher will be the probability. Okay. So the probability a customer will buy a subscription is very closely related to the current movie going rate. The higher the movie going rate, okay, um, compared to the break even, the higher the probability, the smaller it's not. Okay. So in other words, that probability of buying a subscription is not a 50-50 proposition. So if it is 50-50 proposition, this is what the probability will look like. So whatever the current movie going rate may be, it's constant 50%, and that doesn't make any sense at all. So we can straight away reject this approach. The second possibility is that we it it gradually increases, okay, to 1 as the movie going rate increases from near 0 to a large number. Okay. Now this is definitely better than a constant probability, but it still doesn't make sense because if if the break-even point is 1.1, somewhere around here, somebody whose current movie going rate is 2 is definitely going to have a very high probability of subscription, not just relatively little bit higher than somebody at 1.1. So the linear increase in probability is also not reasonable. You would like to see right after the most reasonable shape will be with the break-even point. It should increase quite steeply and then taper off. As the number of movies, current movie going rate increases. So a more non-linear shape is what is reasonable. So we can reject this model also as unreasonable. So a shape something like this is what is reasonable, because here is the break-even movie going rate. So at that point, you can say that subscription is 50-50. Okay, so whether the person buys subscription or not is going to break even. So it's going to be about 50-50, maybe a little bit more than 50-50. But as the movie going rate is smaller and smaller compared to the break even, then the probability will decline. Okay? And it's not going to be 0, because there is a possibility that somebody who goes to movie once in, I don't know, 3 months or so, may want to start going maybe a couple of movies a month. Maybe, there's a small probability, but we can say that it is not 0. So it starts off somewhere around here and slowly increases as the movie going rate comes closer to the break even rate, and after that it should increase steadily, and after some point it should reach very close to 1, and then it is close to 1, which means near certainty that they will buy a subscription. So what kind of mathematical formulation will give you a shape like this for probability? So the mathematical function that will give you a curve like this is this: 1 over 1 plus e to the power of minus x. So as you see, if you assume different values of x and insert it into this function, so when x is 0, what you get out of this function is 0.5. Okay. And if you have a very small negative number for x, then you get a value very close to 0. It's not 0, but very close to 0. Might as well be 0. And similarly, if you have a x value that is really large, then you get a value close to 1. So this function gives you a number between 0 and 1, which is what we want for probability. So probability cannot be negative, probability cannot be greater than 1. And when x is 0, you get a probability of 0.5. So that would be like the break-even point, right? So if your current movie going rate is equal to the break-even movie going rate, then you get a probability 50-50. So you can say that x is the difference between current movie going rate and the break-even point. So if the current movie going rate, if we take x to be current movie going rate minus break-even point, so at that, the current movie going rate is smaller than break-even point, so you will get negative values for x. Okay, so then you get smaller probability than 0.5, and further you go out here, the further the more greater it is, less than the current movie break-even point, the larger negative value x will be, and smaller the probability will be. And the opposite is true on this side. So that works out really good. So we can say that x can be current movie going rate minus the break-even rate. Okay. But there is one problem with that. So what we want to see is that in this area, okay, as you get closer to 0 for x, that is current movie going rate minus break even, you want the probability to increase faster than increase around here or increase around here. How much faster? Okay, that is going to depend upon how the movie going behavior of customers. Whether as you get closer to the break-even point, will they increase their movie going rate faster? So there must be some factor that increases the or affects the rate with which the x increases, and therefore the probability increases. So the mid portion, whether it increases gradually or whether it increases sharply, is going to depend upon how sensitive the customers are with respect to their movie going behavior as they get close to the break-even point. Okay, so we need to do some tinkering with respect to how we get the x. X, for sure, x is going to be a function of current movie going rate minus break-even movie going rate, and what other modification should we do to get this x. So we'll look at that in the next video.